Next up is program number 16. Write a Java program to implement the concept of threading by extending the thread class. Now, there are many ways to create a thread class. So in this program, we'll see one way of creating a thread class, that is by extending the thread class, which is present in the package java.lang and the class name .thread. So to demonstrate this, we have class A, which extends the class thread. So with the help of this, we are making the class A as a thread class. So any program which is created as a thread must have this method called as run. So as class A is extending thread, we have to implement what operation this thread must perform in the run method. So whatever operation you want your thread to perform, that code must be put in the run method. Right? Similarly, we have one more class, class B, which again extends thread class, which also has a run method. So totally we have 3 classes in this program. All the 3 classes are extending the thread class. Each class has its own run method and own definition for its own run method. We are trying to just demonstrate how thread works. So we just have a counter in each run method. It is just to display the numbers 1 to 5 so that the thread is up and running. Just to demonstrate that, we have these 3 classes which are extending the thread class, and each class has its own definition for run. So in your operating system, each core can be divided into threads, and each thread can run its own piece of code. It again depends on how the implementation of your operating system is, but you can increase your efficiency, that is usage of your CPU, to the maximum core with the help of dividing a normal program into a thread program, so that each individual thread can run on its own. For example, if I have a process, I'll divide each process into n number of threads so that each thread can run individually. But if you have process, then each process has to wait for some time in the operating system for it to be executed. Even thread has its own implications, but obviously inside a single process, you can have a number of threads, which will increase the efficiency of your processing. Now, the most important part of your thread program is the start method. So how does the start method and the run method work? Now you have to remember the life cycle of a thread. So in the first stage, a thread is created in the new state, correct? Then you have to move the thread to the running state. To do that, we have to start the thread. So for that reason, we have this start method. Your thread has to go through all the cycles, all the stages in the life cycle. For that reason, the first step is to start the thread. So new a dot start will start this thread. Then the code inside the run method is executed based on the availability of the CPU. If everything is fine, then your thread is up and ready to run in the running state. So based on the requirement of the thread, if it has to go to the waiting state or you can directly execute your thread, everything depends on the implementation and the particular state of your CPU and the operating system. So if everything is fine, your thread will run and execute and finally reach the terminated state. So you should remember the thread life cycle for this to understand. So here we are trying to start all the three threads. So once all the three threads are working, it depends on the operating system architecture, the current state of the CPU, and so many things to the system. But ultimately, the intention is to increase the efficiency by dividing your large program into small threads so that everything is running parallelly, which will increase the efficiency of your program. Now let us run and check and try to match the code with the output. Now, as you can see, first we have started thread A. So once A dot start is executed, it will go to this run method. Inside the run, we have a for loop to display this text and the count. So the output for the run method of class A is here, that is thread A. Similarly, after completion, when it reaches terminated state, we are trying to depict that by a print statement, exit from thread A. Similarly, we have class B, which is working similar to thread A. Again here we are starting the thread. Then the run method of the thread B is executed 5 times. Finally, to depict the terminated state, we are displaying the message here. Similarly, we have the output for thread C. So this is a simple program to demonstrate how you can divide your program into threads by extending the thread class. And why is it important? Because with the help of threading, you can increase the efficiency of your processing. We have many ways to create a thread program. This is one way of creating a thread program.